All right, starting out with the infinite desktop again. We're going to move on to angles here. So lesson 4 is all about angles. So the first thing that we're going to be talking about, I'm going to use my straight edge. Yours don't have to be perfectly straight, but just I'm going to draw in a few angles here. And I'm going to give them some names. So these are all made up out of rays and lines. I'm going to call this point in the center here A. And then going around, I'm going to go B, C, D, E, F, and we'll call this one G. I'm also going to number these angles. So this first one up here I'm going to call angle 1. This is angle 2, angle 3, 4, 5, and 6. Alright, so now there's a few different ways that you can name your angles. So that's the first thing that we're going to talk about. So angles can be named with 3 points. And when you name them with 3 points, you want to make sure that the vertex of the angle, so with the vertex in the middle. So it's not just the 3 points in any order like it is with a line. You need to have the vertex in the middle so that you know which angle you're talking about. So an example here, this angle right here, and I'm going to mark that with a different color. I'll mark it with green. So the green angle that I'm marking right there, that can be named a few different ways. I can call it angle 1 because I have a 1 in there. I can also call it angle GAB or angle BAG. It isn't angle GBA because that would be an angle formed up here, and it isn't angle BGA because that would be up here. The vertex of the angle has to go in the middle. Now, the sides of the angles are the first and second, and the second and third letters. So, for example, angle 1 here, let me switch back to black, has sides. Line segment GA, or actually ray GA, and I'm going to mark it as line segment AB. Now, if you were to use this other one, it would be BA and AG, but those are the same line segment. Okay, so these are the sides of this angle here. So for example, if I were to switch this up and let's look at angle 4 down here, can you think of 3 different ways that you can write angle 4? Pause the video and just give it a try. Okay, so I could call it angle 4, that's one way. I could call it angle DAE, so D to A to E, or I could call it angle EAD, E to A to D. This has a vertex of A, and it has sides DA and AE. All right. Now, that's kind of the basics of naming angles. Let's also talk about the size of different angles. So, in general, there's a few different types of angles. So we'll call this types of angles. So the first type is going to be acute. So type 1, and we'll call this acute. An acute angle has a measure that is less than 90 degrees. Meaning if you use a protractor, it would be 10, 20, 30, 40, up to 90, but not including 90. Measures less than 90 degrees. And acute angles, I always think of them as pointy. It looks something like that. Next, we have right angles. And these are exactly equal to 90 degrees. They're special because we use them all over the place. There's even carpenter's tools that measure right angles. So these measure exactly 90 degrees. And right angles are marked with a little square inside the angle itself, just like that. Next, there's obtuse. So part 3, obtuse angles. These are angles that measure more than 90 degrees. So an example of an obtuse angle, I always think of them as being wide. Be something like that. Okay. And the last kind of angle we'll talk about, and then we'll talk about bisectors. So the last type of angle is 4. These are going to be straight angles. These are just a flat straight line. These will measure 180 degrees. And so a straight angle is just a flat line like that. Okay, so on the assignment for today, there is some algebra that didn't make it into my original version of the notes here. So let's take a look at a situation. Let's say that we have, I'm going to draw a few different angles here, and I'm just kind of eyeballing it, so my measures aren't going to be exact. And some weird stuff's happening down there, but I think I can cover it up if I just make a great big dot right there. Okay. So I'm going to measure these, or I'm not going to measure these, I'm going to name these points. We're going to call this A, we're going to call the center point B, this is C, this is D, this is E, and this is F. So to start out, I'm going to say that ray, endpoint, and then goes on for forever. So ray BC bisects angle ABD. Now what it means to bisect, and we talked about this a bit with line segments, but with angles, a bisector splits an angle into 2 equal sections. So that means that angle ABC is congruent to angle CBD. So let's say that angle ABC is equal to, let's say, 8x plus 20. And then we'll say angle CBD, I know, we're throwing algebra into this, CBD is equal to 6x plus 32. We want to solve for x first. So solve for x. And then we want to use that to find the measure of a specific angle. So find the measure, this means measure how many degrees, of angle, let's say, ABC. Alright, so since we know that these two angles are congruent to each other, we know that ABC is congruent to CBD, and we know that because of the word bisect. That means that we can take these two algebraic expressions and set them equal to each other. So by doing that, I'm going to have 8x plus 20 equal to 6x plus 32. Now solving for x is just like what you did back in Algebra 1. I'll subtract 6x from both sides and subtract 20 from both sides, and that'll leave me with 2x equals 12, which means x is equal to 6. Now if I substitute that back in to find the measure of angle ABC, I can really do either of these, but for funsies I'll do ABC. So ABC is equal to 8 times 6 plus 20, which is 8 times 6 is 48. 48 plus 20 is 68 degrees. You have a couple problems on your assignment that are like that. Okay, So that kind of covers the basics of angles. If there's more that I need to go over to help keep this kind of clear for you guys, then let me know. Otherwise, have yourselves a great day.